The increasing function p gives the number of followers in thousands for a new musical group on a social media site. The table gives the values of p for selected values of t in months since the musical group created their account on this social media site. If a model is constructed to represent these data, which of the following best applies to the situation? So we can look at the data in this table. Let's rewrite this here so we can label around and measure some values. Looking at the answer choices, we see that we have to distinguish whether this relationship, this model, is either linear, like in A, B, or B, or it's an exponential graph, like in C or D. So let's look at the changes. So in the input values, the independent variable, we see that every time it's just changing by 1, so it's a constant change. So let's see the changes in P of t, the dependent variable. So we see here that this increases by 10 from 20 to 30, then it increases by 15 from 30 to 40, and then it increases by 17. Oh, sorry. This increases by 20. So 67.5 minus 45 is equal to 22.5. And then from 101.25 to 67.5, we can just quickly calculate that. 101.25 minus 67.5. That gives us 33.75. Okay, so we see that the change is not constant. We see that for every one change in t, the dependent variable changes by what seems an increasing amount. So that means we can rule out the linear equations, because a linear equation requires that the change be constant. There is a constant slope, constant change in y for every change in x. But this x seems to be an exponential graph, so let's find the rate of change in p of t. So we see that we went from 10 to 15. So what this basically did is we multiplied by 1.5. We multiplied 10 by 1.5 to get 15. Then we went from 15 to 22.5. Well, if this is also 1.5 change, then that means 0.5 of 15 is 7.5. And if we add that to 15, we get 22.5. So it does seem, in fact, to be an increase in the rate of change of 1.5 every time. And 1.5 is just the same as writing. There's a factor of the rate of change of the change in P of t is 3 over 2. So if we were writing our exponential function, the base of the exponent would be 3 over 2 raised to the t power. Now to find the coefficient out front, that would just be the initial value when t is equal to 0. So it's 20. So this is our exponential equation. And we see this is equal to d. We could have also told that it easily wasn't c, because c has 2/3. And when the base of the exponent, when the base is less than 1, that means it's a decaying function, meaning the change in the rate of change would be getting smaller every time. So instead of increasing the difference between the values, the differences in the values would be, their rate of change would be going down. But we see that this is an exponential function that is growing faster and faster. That's because the b value is greater than 1. So D is the correct answer.